Hi all, good morning to everyone. So far we have discussed the fundamentals in one-dimensional arrays. We have explored the searching and conventional sorting algorithms. Next, we are going to see the second kind of an array called multi-dimensional array. Have any doubts in the previous session? Have any doubts in the previous session? You can ask. Otherwise, we move on to the next topic called multi-dimensional arrays. Multi-dimensional arrays are arrays of arrays. For example, here in a one-dimensional array, we have one row and several columns, say n columns. For example, here 4, 5, 8, 2, 0. Indices are 1, 2, 3, or we can assume the indices 0, 1, 2, 3, 4. So this is one-dimensional array, say X, with 5 elements that we can define as int x of 5. Int is the data type, x is the array name, 5 is the size of the array. Indices 0, 1, 2, 3, 4. The index starts at 0. Here we have how many rows exactly? We have one row. How many columns? N columns we have. This is the first column, second column, third column, fourth column, and fifth column. That's what the structure is to be a one-dimensional array. Then we have multiple rows with the fixed column size. We can make a one-dimensional array into a multi-dimensional array, or we can make it as a two-dimensional array. For example, we have a two-dimensional array which consists of two dimensions. One represents the row size and another one represents the column size. So when the row size is exactly 1, a two-dimensional array becomes a one-dimensional array. When row size is greater than 1, here we have row size is greater than 1. And column size, right? This is also greater than or equal to 1. For example, consider this representation. First row, second row, third row. Having 5 elements in each row. For example, we can initialize the values 0, 1, 2, 5, 8, 6, 7, 3, 2, 0, 5, 2, 1, 8, minus 1. In this case, we have two dimensions. One, this represents the row number, say row 1, row 2, row 3. This direction here, this is column 1, column 2, column 3, column 4, column 5. For example, having 3 rows and 5 columns, we have 3 into 5 is equal to 15 elements of that. So this stage, the matrix consists of the product of its dimensions, number of elements, 3 into 5 are 15 elements of that. Since the row size is greater than 1, and the column size is greater than or equal to 1. This is said to be a two-dimensional array. In two-dimensional array, you need to think of several one-dimensional arrays are merged. This is the first one-dimensional array, and this is the second one-dimensional array, and this is the third one-dimensional array. So having several one-dimensional arrays, we can merge them into a single array called a two-dimensional arrays, which consists of only two dimensions. In this case, we can define the matrix or array using this general form. Data type, for example, int, then specify the name of the array name, then specify the dimension 1, then specify the dimension 2, semicolon. T1 is the first dimension, D2 is the second dimension. As we have seen earlier, data type, array name, then size of the array. Here specify two dimensions. For example, in some A 5, 4. What is the meaning? Capital A is a two-dimensional array. Two-dimensional array. Int, this signifies that there are 20 elements. 20 elements which are of type integer type, because array is a collection of similar type. 5, which indicates the first dimension, or we can assuming that the row size is 5. 4 indicates the second dimension, which means its column size is 4. So totally the matrix or an array A consists of 5 into 4 is equal to 20 elements. So how do we represent structurally the array representation 5, 4? Represent 5 rows. In each row specify exactly 4 columns. First row, second row, third row, fourth row. So this is row 1, row 2, row 3, row 4, one more row, right? Fifth row. 5 rows are right. Row 5. With respect to column, we have 4 columns. Say first column C1. This is second column C2. Then next column C3. Next column C4. Array name is A, having a two dimensions. How do we access the indices? The indices are right are array elements using the indices. Here the index is 0, 0, because this is the 0th row. First row is actually 0th row. Then 0, 1, 0, 2, 0, 3. Then this is the first row. So the indices are 1, 0, 1, 1, 1, 2, 1, 3. This is the second row index 2 0 2 1 2 2. This is 2 3. And this is the third row 3 0 3 1 3 2 3 3. Two subscripts are archived. Fourth row 4 0 4 1 4 2 4 3. So if we say the index ij, writing suppose a of I comma j, a of I comma j defines the element at ith row and jth column. The element at ith row and jth column is being defined as a of I comma j, or simply this I comma ij, right? This is this index representation. For example, this is I, this is j. First index is I, second index is j. First index corresponds to the row, second index corresponds to the column. So what about I and j? I ranges from 0 less than or equal to I less than or equal to first dimension minus 1, T1 minus 1. J ranges from 0 less than or equal to j less than or equal to T2 minus 1, second dimension minus 1. As we have seen earlier, for a one-dimensional array, the index ranges from 0 to array size minus 1. Since here we have two dimensions, so first index ranges from 0 to first dimension, right? Size of the first dimension minus 1. Second, right, index j ranges from 0 to second dimension, size of the second dimension minus 1. So this way, the element at ith row and jth column is being accessed as a of I comma j. As usual, we can access the elements like this a of I comma j equal to 1. We can access I and j using that range. For example, a of 0 0 is 0. A of 1 0 is 1. A of 2 0 is 3. Likewise, we can make the assignment statements, or we can access the ith row jth element, ith row jth column element as array name of I comma j, where I defines the row index, j defines the column index. So to define a multi-dimensional array, say a two-dimensional array, we need to use this representation. In case if you want to use the multi-dimensional array with 3 dimensions, for example, we can define int a of 2 rows, 3 columns, and the third dimension is, for example, 4. In this case, we need to consider this as x, y, z axis, x dimension, y dimension, z dimension. Here, 2 elements, 3 elements, and 4 elements. So totally 2 into 3 into 4, 6 into 4, 24 elements, 24 memory locations are allocated to the array variable A. As usual here, array index rate starts at 0, x0, y0, z0. Then x1, y1, z1, x2, y2, z2. Likewise, we can access the corresponding dimensions so that 24 elements can be accessible. 24 memory locations are created to this array, 3 dimensions. Likewise, you can have 4 dimensional, right? 4 dimensions, 5 dimensions, 6 dimensions. You can have the multi-dimensional arrays like this. Now, considering this a 2-dimensional array, let us consider the matrix representation so that we can define a 2-dimensional array as we done for a 1-dimensional array. We can make the initialization, or we can get the keyboard input values, or we can separately initialize the values, right? One at a time. That way, right, we can process the 2-dimensional arrays. Now have a look into this example so that you will understand how to define a 2-dimensional array and initialize it. As include stdio.h into main. Suppose we do like to define a 2-dimensional array with 5 rows and 3 columns. In a mix of 5 rows, 3 columns. This is just the declaration. So once we declare this a 2-dimensional array, we can initialize the values, right? 15 values. How do we initialize the 15 values? X 0 0 is 0. X 0 through first column. For example, 1. X 0 through second column, say 2. X 0 through X 0 through 0, 1, 2, 3. Third column. This is 3. So first row, 0th row with 4 elements are filled. 0, this is the 0th index. This is the first. This is second, and this is the third index. Then likewise.
Or then 4 columns will be there, no sir.
Yeah, 4 columns. Here 3 columns. So 3 columns. 0, 1, 2. This would be right. Move to the text too. Okay. So having only 3 columns, right? This is the first column. Since it starts at 0, right? So you need to end with, right? A second dimension -1, 0, 2. That's correct. Having the second row, edit, copy, we can make edit, paste, edit, paste, edit, paste, edit, paste, right? Having, right, 5 rows. Now this is a completely the elements at first row. This is actually 0th row elements, right? These are the elements at first row. 0, 1, 2. Let us number it continuously. This is 3, 4, 5. Then 0th row, first row, second row. 2, 0. This is 2, 1. This is 2, 2. Numbering the elements, say for example 6, 7, and this is 8. Then third row, 3, 0, 3, 1, 3, 2, 6, 7, 8. Say this is 9. This is 10. This is 11. Then have it as 4, 0, 4, 1, 4, 2, 12, 13, 14. So 5 of 3, 5, 3, right? Totally 15 elements. 5 rows, each row with exactly 3 columns. 5 into 3, 15 elements are initialized. This is one possible way to initialize a 2-dimensional array. Now if you want to print the result, right? Print the array X array, two-dimensional array. So use two for loops for int I is equal to 0, I less than, what is the size? Row size, I less than 5, I plus plus. For int j is equal to 0, j less than column size 3, j plus plus. Here we do like to use printf slash n x of percentage d is equal to percentage d comma I comma j comma x of I g. We are printing the index along with its array element. Now let us shift code letter 0 F9 roll F9. Have a look into this outcome. X of 0 0 is 0 as initialized. X of 0 1, right? We have printed with its initialization with its right formatting x1 1, right? 1 x0 x0 1 1, sorry, x0 2 2, etc. x40 12, 41 13, 42 14. This is one possible way to initialize a two-dimensional array. Have any doubts?
No doubt, sir.
Okay. The second possible way is to initialize a two-dimensional array similar to one-dimensional array. I save the file into a new name, say CP76, initializing a two-dimensional array. Consider this highlighted statement. X 0 0 0 0 1 1 x 0 2 2. This is clearly the zeroth row of a two-dimensional array. The zeroth row, that means actually the first row, right? So the zeroth row actually consists of three elements, say 0 1 2. So just to think of the representation, for example, here I write int x of, what is our column size? Column size is 3. So int x of 3, if you want to initialize 3 elements, we can initialize like this. Int x array is equal to 1, 2, 3. Now what is our initialization? 0, 1, 2. 0, 1, 2. This is actually the initializer for 0th row. This is clearly a one-dimensional array. Likewise, 0, 1, 2, then what are our values? 3, 4, 5. Okay, continuously 3, 4, 5. This is the initializer for the first row. Then 5, okay, 6, 7, 8. This is the initializer for the next one-dimensional array. 9, 10, 11. This is the initializer for the next one-dimensional array. 12, 13, 14. This is the initializer for the fourth, that means fifth one-dimensional array. Having these initializers, since we have already discussed that to initialize three numbers or three elements in the array X, we used this generic format. Array elements are separated with the comma operator and enclosed within the opening and the closing curly braces. So just think of this is the one-dimensional array X of 0 and this is the next one-dimensional array X of 1, next one-dimensional array X of 2, next one-dimensional array X of 3, next one-dimensional array X of 4. Since these are array of arrays, multi-dimensional arrays, right? We can have the representation as int x 2 dimensions. This is equal to specify the initializers as usual 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then once again, right, enclose is several initializers within the opening and the closing curly brace, followed by semicolon, so that the same initialization is taken here. So this is clearly the value of x of 0, and this is clearly the initializer for x of 1. X of 2 is initialized like this. X of 3, the next one-dimensional array, is initialized like this. X of 4, the last one-dimensional array, is initialized as 12, 13, and 14. Now let us check with this example. I remove these explicit initializers. Instead, I try to write x 2 dimensions, empty dimensions. This is equal to 0, 1, 2, then 3, 4, 5, then 6, 7, 8, then 9, 10, 11, then 12, 13, 14. Once again, try to close the curly brace followed by semicolon. What is the meaning? First one-dimensional array initializer is provided. Second one-dimensional array initializer. Third one-dimensional array. Fourth one-dimensional array. Fifth one-dimensional array initializers. So clearly 5 one-dimensional arrays initializers are provided, where each one-dimensional array consists of exactly 3 columns. Now let us run the code, save, control F9. What is missing? Int x array is equal to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Sir,
F9.
we didn't mention the size of the row and the columns.
Size of the row, for example, 5 rows, 3 columns. F9. Okay. Having right the row size right as 5 and the column size is 3. What happened? Control F9. Here we have got the output that is similar to the previous program. The previous program, say 15 statements are returned separately to initialize 0, 0, 0, 1, etc. 4, 0, 4, 1, 4, 2. The same thing could be achieved like a one-dimensional array initialization. So please think this is one-dimensional array initializer. This is the second one-dimensional array initializer. This is the third one-dimensional array initializer. This is the fourth one-dimensional array initializer. And this is the fifth one-dimensional array initializer. It seems 5 one-dimensional arrays are there. We have combined the 5 one-dimensional arrays into a 2-dimensional array with 5 rows and 3 columns. In this case, if you miss both the dimensions, very important thing, to try to make a note on these things. Edit, copy, edit, paste. This is okay. If you mention both dimensions, it will work because you are explicitly telling what is the row size and what is the column size. When you miss the row size and the column size, this will not work. But in case of one-dimensional arrays, right, we have tested all possibilities. Here, in case of two-dimensional array, you must specify, right, to 2 dimensions, right, either as we done the first line or specify first dimension 5 before that, right, I write this one. This results in error. And the third possibility, I try to miss the second dimension. File save F9. What happens? It results in error message. Or if I miss the first dimension and keep the second dimension as 3, F9, this is perfectly valid, right? So make a note on this one. You need not inform how many number of rows are there. For example, even in a one-dimensional array, we have initialized, right? Like this. Int x array is equal to 1, 2, 3. You need not mention how many number of rows are there, or here you need not mention the column size, right? 1, 2, 3, having 3 elements into x or 3. Not required. Likewise, here 5 one-dimensional arrays are there, right? The size is not required here. Control F9. We are getting the same result here, but you must specify the column size, that is important. So when you have 2 dimensions, to initialize that array, you need to specify both dimensions. If you leave both dimensions empty, that results in error. Or you can specify second dimension, right? That is mandatory. First dimension, right? This is not required. In case if you put, right, for example, 6, 3, now what happens? Control F9. Up to right 4, 2, we have printed the values. Then the next row, right, by default, assuming the 0 values, because by default array elements are assigned, right, the values, for example, are garbage values that you need to check. 6, 3, for example, here I put a 6. Control F9. 5, 0, 5, 1, 5, 2, right? The values are assigned as zeros. So the important thing is here 6, which indicates that 6 rows, 1, 2, 3, 4, 5, only 5 initializers are provided. 6 row initializer is missing. So it is assumed to be 0 values. But if I say 3, 3, what is the meaning? We are trying to assign 3 rows with 3 columns. This results in error because array size here 1, 2, 3, 4, 5. 5 initializers are provided. We are mentioned only 3 rows. So contradictory things happen. Clearly specify the row size or completely leave the row size. Column size is required. For example, instead of 3 here, if I put carefully note it, I have dedicated to this one. If I put 2 here, this results in error message because we are informing the compiler that each one-dimensional array consists of exactly 2 columns. But why we have given unnecessarily 3 initializers, that results in the problem. In case if I put right 4 means even 3 initializers are given. 4th initializer in each row is taken as 0. So this is perfectly valid. So please make a note on these things in a case of 2-dimensional array initialization. 2 dimensions can be provided. If you miss the 2 dimensions blank, that results in error message. You need to specify the second dimension, or you need to specify the dimensions from right to left. In case of 2-dimensional array, one value should be filled. Having 3-dimensional array, say intakes of 5, 3, 2 means here you need to specify last 2 dimensions. Only the first dimension may be missing. So that is the logic of a multi-dimensional arrays. Just to have an idea, how do we initialize a 2-dimensional array? As we have done in the previous example, that is one way. The second way, during the array declaration and definition like this. Third possible way, you can clearly get the input values here instead of printf. You can use scanf, then here $x of ig. Runtime, right? Dynamically, you can get input values into the 2-dimensional array. Have any doubts in multi-dimensional array declaration, initialization? If you have any queries, now you can ask. Any doubts? Okay, now let's illustrate a 2-dimensional array with one example. Let us consider a matrix with m rows and n columns. Have 2 matrices, suppose x and y. Let's find its sum, right? Matrix addition. So please take the next problem. File open CP77. Find the addition of 2 matrices of 2 matrices. That's all. Find the addition of 2 matrices. Assuming that the order of these matrices are, say, m by n, which means m rows and n columns there in each matrix. First matrix should have the dimension m by n. Second matrix should also have the same dimension. Then only the matrix addition is possible. So let's declare 2 matrices of orders m by n. Hash include stdio.h. Having a main function, int main. For example, let us define 2 matrices. Suppose it takes of having 10 rows, 10 columns. Y having 10 rows, 10 columns. Z having 10 rows, 10 columns. Ultimate aim is to find the Z, right? What is Z? Z is obtained as adding the matrices X and Y. So we have defined right enough number of rows and columns. Then we need to get inputs on the variables M and N. So have a printer statement that declare other variables later. Printer slash N. Enter enter the size. What is the size here? Size is M by N. Having a scanner statement, scanner percentage D, comma, ampersand M, comma, ampersand M. Size of the matrices X and Y are obtained. Then what we have to do, we need to input Mn elements corresponding to the first matrix and other Mn elements corresponding to the second matrix. So I write this way: printf slash n, enter X matrix. How do we get X matrix for? As we declare the variables I and j later, I is equal to 0, I less than M, I plus plus, or j is equal to 0, j less than N, j plus plus, and of percentage D, comma, ampersand, xig. That's all. These for loops aligned with the scanf statement extracts the input values for the first matrix E. Then we need to get the same for second matrix. Edit, copy, edit, paste. Enter the second matrix. Array name is changed. That's all. Remaining code, there is no change. The matrix Z is actually obtained by taking the corresponding elements from ith row and jth column in matrices X and Y. Those corresponding elements, right, are going to be added, and the result is assigned at the correct position in the third array Z. So, having the computation, for example, here find Z array is equal to X array plus Y array. How do we find the computation? Matrix addition. You know that x00 is added with y00, and the result is being put in 0th row, 0th column of matrix Z. Then 0th row, first element in corresponding two matrices are added.
Sir, the closing brackets have to be given for each scanf, right?
Pardon?
For each scanf, closing bracket should be given, right?
Yeah, closing bracket is given. Okay, that's missing. So we need to take the indices I and j in matrices X and Y. Corresponding elements are extracted and the result is added and put in the ith row and the jth column in the resultant matrix Z. So shall we have the computation like this? For I is equal to 0, I less than m, I plus plus. Then inner for loop for j is equal to 0, j less than n, j plus plus. Writing what is Zij? This is actually obtained by adding the corresponding elements in matrices X and Y. Xij, put Yij, semicolon. Inner for loop is closed here. Then outer orbit is closed here. So this is the simplest way to find out the matrix addition. Since you know that the matrix addition that takes two matrices which are of equal size. Suppose 1, 2, 3, 4, 5, 6, 7, 8. This is equal to taking the elements at correct positions. This is 1, 1. Here this is 1, 1. We can write 1 plus 5. Then 2 plus 6. 3 plus 7. 4 plus 8. This is equal to 6, 8, 10, 12. For example, corresponding positions, right, are considered and the elements at those positions are added and the result is updated in the variable z. For example, this is the input matrix corresponding to X array. This is the input matrix corresponding to Y array. The resultant matrix Z is obtained like this. So we have used two for loops and the computation is written as Zij is equal to Xij plus Yij. Then finally we need to print the matrix or print Z array values in the matrix form. So we need to write the two for loops again. 1 minute. Okay. Having the two for loops. Edit, copy, edit, paste. Have a look into this printer statement. Printer percentage d space comma resultant matrix is z of I comma z. If we put like this, what happens? Let's check it first. Return 0. Okay. We have to declare the variables I, j, m, n int I, j, m, n. Okay. F9. Compile time errors. Control F9. Enter the size of m by n. For example, I put 2 space 2. That means 2 by 2 matrix. Enter X array. X array value should be given in 2 by 2 format. Or even input the values right in the single row or 4 rows, right? Whatever you want. For example, I do like to give the input like this 1, 2, 3, 4. As in the matrix representation. Because when you input X array, we need to input exactly 4 elements. Until you enter 4 elements, right, the cursor is blinking, right? So 4 elements, 1, 2, 3, 4 are given, that's all. Input to the first matrix is over. Then input to the second matrix, for example, I write 5, 6, 7 space 8. Input to the second matrix is over. Then the resultant matrix is obtained by adding these to 1 plus 5, 6, 2 plus 6, 8, 3 plus 7, 10, right? Then 4 plus 8, 12. So 10, 12, right? This will be displayed in the next row, new row. So how do we make to print the resultant value, say 10, 12 into the new row? That is the question. For each row, for each value of I, what happens? This is z of I comma c prints the value at ith row and jth column elements. So once it is over, when j ranges from 0 to n minus 1, when all the values in that row are completely printed, before start to print the next row, need to give the new line character printf /n, so that what happens once one row is printed, before printing the next row, the same line or in the next line, you need to use the structured representation printf1/n empty/n. Now in this case, have a look into this outcome. Last line 6, 8, 10, 12. The elements are printed in the single row. Now have a look into this representation. 1, 2, 3, 4, 5, 6, 7, 8. It seems the result is 6, 8, 10, 12. So before that, right, you try to give the message here. Printf /n z is equal to x plus y. Z is equal to x plus y /n. Control F9 2 by 2 1 2 sorry 1 2 3 4 5 6 7 8. You can see the message z is equal to x plus y. As we have done the implementation of matrix addition, corresponding elements are added. As we check here, we need to expect the result 6 8 3 plus 4, that's 10 6 8 10 12. Here we have the result 6 8 in the input 0 through 10 12 in the first one. This is matrix addition. We have printed the result right in the matrix format. So after printing the ith row elements completely, before this printing I plus 1th row values, we are forcing the output to the new line character printf/n, so that the next row outcomes are to be printed in the new row. That is a logic to output the given matrix, right? In the given two-dimensional array in the matrix form. So Z is a two-dimensional array. A two-dimensional array Z is printed in the corresponding matrix format. If you want to print the input matrices X and Y are also in the matrix format, you can try to copy paste the code. The matrix state Z, this will be changed to X of Ig and Y of Ig, so that input elements are also going to be printed in the matrix format, and the result Z finds the addition of two matrices X and Y. Have any doubts in this example? Have any doubts?
No, sir.
In case if you want to give the order right in a different way, suppose I do want to give 3 by 3. Enter X array, 3 rows, 3 columns. So I can input this way conveniently for the matrix format. 4, 2, 1, something. Enter Y array values. 1, 1, 1, 0, 1, 2, 0. Now the resultant matrix Z is obtained by adding the elements at the corresponding positions 0, 0, 2. Array size -1 to array size -1. So that it sees the input elements are in the matrix format. output is also in the form of a matrix form. Z is equal to x plus y. To change M and N, for example, control F9, matrix row size 2, column size 1. That means 2 rows, 1 column, 12, 45. Enter Y matrix, say 28, 12, 145 is given. Okay. 25. Z is equal to x plus y. It seems what happens? 40, 150, 28 plus 12, 30 plus 10, 40 is printed. 145 plus 5, 50 is printed. Because first one, 12, 145, right? One row, sorry, 2 rows, 1 column. Here also 28, 5, or 2 rows, 1 column. So the resultant matrix also have 2 rows, 1 column. That 1 column is 40, 150. Or 2 rows elements are 40 as the first row element, 240 as, sorry, 40 as the first row element, and 150, right, as the second row element. 28 plus 12, 40, 145 plus 5, 150. 40 as the first row element, 150 as the second row element. Resultant matrix also have the same dimension. What is the dimension? 2 by 1. Having right one row and one column, say 1, 1, enter one element 100, enter one element 200. The resultant matrix consists of exactly one row, one column. So one row, one column. The element is just 0, 0. Is the term 0, 0. That is obtained by adding x of 0, 0 and y of 0, 0. X of 0, 0 is 100. Y of 0, 0 is 200. 100 plus 200, it seems z of 0, 0 is 3. Even if you want to input the elements in a single row, no problem. That is perfectly valid. For example, I do want to show the dimension as suppose 4 by 2. 4 by 2 means, right, what is its size? 4 into 2, right? 4 into 2, right? 8 elements. For example, I put 0, 0, 0, 0, 4 elements, 0, 0, 0, 0. First matrix, 8 elements are obtained. Second matrix, 8 elements, say 1, 1, 1, 1, 1, 1, 1, 1. Second matrix, 8 elements are obtained. Resultant matrix, which consists of the size 4 by 2, 4 rows. In each row, we have exactly how many columns? So 2 columns. So 1, 1, 1, 1, 1, 1, 1, 1. 4 rows, each row with exactly 2 columns. So resultant matrix dimension is 4 by 2. 4 rows with the 2 columns. 1, 1, 1, 1, 1, 1, 1, 1. That's all. This is the application of arrays, right? Multi-dimensional arrays in solving matrix operations. Likewise, we can find the difference between two matrices and multiplying the matrix by some scalar alpha greater than 0. And we can find, right, several applications based on these multi-dimensional arrays. We can have, right, 3-dimensional arrays, right, 4-dimensional, 5-dimensional arrays. We can introduce the concept of, right, finding the transpose of the matrix or matrix differences, product of the matrices. These operations can also be solved using this or two-dimensional arrays representation. Have any doubts? Have any doubts? Okay, please go through this session. We will continue in the next session. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.